Welcome to Radio Signals. My name is Mark, and my call sign is N9WIB. This is the Technician License Series, lecture number 16, and today we're going to cover Communications, Part 1. During this communications lecture, we will cover the basics of how hams communicate over the radio. We will start with reviewing the band plans, followed by repeater communication, simplex communication, how to call CQ on HF and how to call CQ on VHF and UHF frequencies, followed by a review of Q codes and Maidenhead grid squares. The term band plan can be confusing. It is frequently confused with frequency chart. Frequency chart is different than a band plan. A frequency chart is a designated FCC legal operating frequency allocation. And there are charts available of the frequency allocations on the ARRL website and throughout other sources on the internet. A band plan is something different. A band plan is a voluntary agreement where various modes should be operated within the legally defined frequency allocations. And this essentially means where you can operate CW or Morse code. Are you going to operate on the upper ends of the 20-meter band or the lower ends of the 20-meter band? How about digital modes? What frequencies are normally used for digital modes? Or what frequencies can be used for slow scan television? Again, these aren't legal frequency allocations, but they're generally agreed upon by the amateur community that someone will operate CW on the lower portion of the bands and digital communications on the lower portions of the HF bands, and typically reserve the higher portions of the higher frequencies on the same 20 or 40 meter or 80 meter band for single sideband phone communication. It's essentially good amateur practice, and we need to be courteous to follow the band practice plan. So on HF, again, CW and digital modes are normally operated in the lower parts. On 40 meters, this is typically done between 7.025 and 7.125 megahertz. This is where you will generally hear Morse code and digital operations. So can you operate phone or single sideband within that frequency space? Sure. However, as you remember, a single sideband has a much wider bandwidth than CW or digital. So you're going to be compromising and using up a lot of the bandwidth on that lower portion and probably make a lot of different people mad that you're operating within that range. For 40 meters, the frequency band plan for 7.125 to 7.300 is typically single sideband and phone operation. And again, can you operate CW and digital in this region? Sure, you can. It's not illegal, but it's good amateur practice to follow the band plan that the other amateur radio operators throughout recent history have set forth. And beacons also exist. So beacons exist on certain frequencies and they're designated stations across the world, and they're utilized to determine propagation conditions. So let's say there's a beacon station in London and maybe another one in South America and another one in Africa. So these beacons have these designated frequencies within the FCC determined allocations, but they're agreed to be within a certain band planned or frequency so that amateurs can find the frequency and see if the band's open. So if you can hear that station, that means you could potentially make a contact from your home QTH to somebody in South Africa if you can hear the South African beacon, and the same thing to Europe. So if you can hear the beacon in Italy, you can potentially make a contact with Italy. If you can't hear that, then it's probably not even worth trying on that specific frequency. The VHF band plan is, I'll give you a few examples. So 144.20 is the single sideband calling frequency. So you can actually utilize single sideband on VHF on 2 meters. This is not the FM calling frequency, but this is designated for single sideband calling. 144.60 to 144.90 are typically reserved for FM repeater inputs. So you're not going to want to operate potentially simplex or have a QSO on a repeater input. And 145.20 to 145.50 are the repeater outputs. And there are other allocations for the 2-meter band plan for repeater inputs and repeater outputs. These are just some of the examples. And 146.40 to 146.58 is generally reserved for simplex operations. So operator to operator, ham to ham, you can communicate directly within that frequency range. Is it illegal to operate to do a simplex FM conversation on 144.20? No, it's not against the FCC rules. However, it is proper amateur practice or good operating practice to abide by the band plans. And 146.52 is the VHF 2-meter simplex calling frequency. So meaning if you want to make a contact, this is probably where you'd start out. If you're looking to make an FM simplex contact and you're driving to work or on a road trip across the country, if you want to try to talk to another ham and you don't have the repeater frequencies in front of you, you can try calling and just say your call sign and listening or monitoring on 146.52, and somebody may come back to you, and then you can have a conversation on a different frequency after you move off the calling frequency, and we'll get to that in a little bit. Another thing regarding making contacts, make sure you are within your legal frequency allocations based on your amateur privileges. So if you have a technician license, you're going to be operating within a certain frequency allocation based on FCC ham privileges on the various bands. And then also make sure your power settings are within the legal limits based on the band as well. And the first thing you do when you want to make a contact on HF or VHF or UHF is tune to the frequency and just wait. Listen, listen, listen. So first, listen if there's any other traffic on that frequency. The frequency could be in use. There could be two hams having a conversation back and forth. One may have stepped aside for some reason, and they're just waiting for him or her to come back. And just listen, especially with HF. There are things called skip zones. So if you can hear one operator, but you can't hear the other, that may be because that other operator is within the skip zone. So they can actually be having a QSO or a conversation, but you can't hear the other party. So if there's any question, listen first and listen for a period of time, and then ask, is this frequency in use? On HF, again, the golden rule is to tune into the frequency and first listen. Ask if the frequency is in use, and then call CQ, or if you expect to meet somebody else on that same frequency, if you have a friend that you designated time in a certain frequency you'd like to talk to that person, then call the other station directly. Just announce your call sign and call the other person's call sign. But if you don't, if you just want to make a CQ contact, then you would call CQ, CQ, CQ. This is November 9 Whiskey India Bravo calling CQ. And you'd actually repeat that a few times with a pause of several seconds in between transmissions to see if anybody wants to come back to you. Remember, HF is not channelized. It is, you can go from one end of the spectrum of the frequency to the other. So if somebody's watching the waterfall display on their newer radio, or just spinning the dial and tuning between across the band, they need some time to actually pick up your transmission or see your transmission on the waterfall. So I wouldn't just call CQ, this is November 9 Whiskey India Bravo calling CQ, and then stop for a 5-minute time frame. They need time to actually see your transmission on that waterfall, or hear your transmission when they're scanning from the low end of the band to the high end of the band by just rotating the VFO dial, the tuning dial. And on digital or CW modes or Morse code modes, there's the same format essentially, but there are other things that you should know. So there are certain abbreviations that will help you make contacts on digital or CW or communicate more efficiently and effectively. So there's a term called DE, the letter D followed by the letter E, all strung together. And DE essentially means this is or from. So you would say N9WIB, DE, and CW or digital, this is your other call sign, and DE is the abbreviation for that. And if you're transmitting CW or Morse code, at the end of your sentence, you would transmit a K in Morse code. And the K essentially signifies that it's your turn to speak, that my sentence is done. So essentially they're saying over or back to you. And the same thing can be done in digital communication by just putting a K at the end of your sentence to signify that you're actually done with your transmission, and it's now the other party's turn to call or come back to you. On VHF, the procedure is almost the same. So again, the golden rule is listen first, tune into your frequency or tune to your channel on a VHF frequency or your repeater, tune in the channel of your repeater, and then listen first. Listen for a good period of time to make sure no one else is using the repeater. And then you may ask if the frequency is in use. This is not as commonly done as it is on the HF, but it is something courteous to do, especially if you're calling on a simplex frequency or the calling frequencies on VHF or HF. So for VHF, simply state your call sign followed by either the term listening or monitoring. On VHF, on VHF FM modes, you typically do not call CQ, so you would not get on a repeater and say, CQ, 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 this is November 9, Whiskey India Bravo calling CQ. That's generally not done on an HF frequency or a repeater. You would just state your call sign and say listening. So this is N9WIB, listening. And then you would wait for a response. And if you haven't heard anything after a minute or two, you may come back and try again. Say N9WIB listening or N9WIB monitoring. And if you're a new ham, it wouldn't be out of the ordinary for you to say this is your call sign followed by listening, new ham radio operator. So if somebody hears that, they're probably more likely to come back to you to actually make a contact and welcome you into the community. You should, out of courtesy, announce your call sign at the beginning of a transmission and then legally every 10 minutes and at the end of your conversation. So that's the legal requirements and also good operating practice. Repeater contacts. Transmitting to and operating on a repeater is very common in your technician career and probably one of the first things you're going to do. So repeaters essentially receive your signal on an input frequency and then retransmit on an output frequency. And this significantly increases communication range. So you're not just communicating in simplex meaning one frequency to another, one ham to another on the same frequency. You're operating on a repeater. Again, you're transmitting on your frequency, and the repeater is receiving it on an input and retransmitting it on an output frequency. If you want to find local repeaters in your area, you can reference the ARRL repeater directory, or you can scan for local repeaters on your radios. So a lot of radios have scan functions that you can pick up repeaters. And once you hear the repeater's signal, typically the repeaters may identify themselves, let's say at the top of the hour or during a contact. They may announce their call sign either by a automated voice, or they may actually identify themselves by Morse code. So if you know Morse code, you're good. If not, if the repeater announces its call sign in a automated or recorded voice, then you can look up that call sign and find out what the repeater is or where the repeater is and the specific frequency access tones for that repeater. And we'll get into that in a little bit. And if all else fails, you can do an internet search for repeaters within your area. So you can put down amateur radio repeaters and your location and city and see what comes up. Repeaters have an offset or shift, and the repeaters are labeled according to their output frequency or the frequency you hear. So let's say in this area I want to transmit on the 146.88 repeater. So what does that mean? So that 146.88 repeater is the output frequency of the repeater. That's what you hear. So that's what you kind of tune in or dial into, and you can operate on that repeater. The offset or shift is the difference in frequency between the output and the input frequency. And if it's a positive offset, the input frequency is higher than the output frequency. So it'll have a little plus symbol next to it. If it's a negative offset, the input frequency is lower than the output frequency. And those repeaters referenced either on the internet or in the repeater directory will have a minus sign next to them. The 2 meter repeater offsets are typically plus or minus 600 kilohertz. So the offset, the input and the output frequency vary by 600 kilohertz for 2 meter repeaters in general. Some repeaters have a need for repeater access tones. So let's say a repeater may be listening on a frequency of, again, I'm just going to make this up, 146.88 again, but that was the output of the previous repeater I brought up. Let's say it's just listening on that frequency. But a nearby repeater, maybe 25 or 30 miles away, might have the same input. So that would be poor repeater planning, but let's say that maybe propagation conditions are good for VHF. There might be some tropospheric ducting going on, and signals from one repeater may be getting to the other repeater. So you may be activating both repeaters at once when you really only want to activate one. So repeaters solve this problem by having a certain code, a subaudible code associated with them. So this is something you need to actually program into your radio. And every time you transmit or you push your PTT button and try to access a repeater, that subaudible tone will be transmitted along with your push to talk and be transmitted to the repeater. And it will tell the repeater, hey, I'm trying to contact you and I'm trying to activate that specific repeater. Please allow me to transmit, and it will open the output frequency and retransmit your message. So it essentially prevents false activation of a repeater from nearby signals not intended for that specific repeater. And these tones can be called several different terms. One is CTCSS. That's Continuous Tone Coded Squelch System, CTCSS. So you'll see that in your radio operator's manual. And the CTCSS, depending on the brand of radio you have or repeater, is also known as the PL. So you need to know the PL of the repeater to program that subaudible tone or frequency into your radio to activate that repeater. You can find the appropriate tone or frequency on the repeater directory or on the internet search by picking up that certain repeater. There are 38 different frequencies. All of them are below 300 hertz. So one common error or mistake that hams may make or new hams may make is they program in the repeater frequencies and they try to make a contact, and they can hear people talking on the repeater, but for some reason they can't activate the repeater and no one else can hear them. That's because the most likely problem is that you have not programmed in that subaudible tone to actually activate the repeater. You need need to put in that CTCSS tone in the radio and program it, and put in that PL tone to actually hit that repeater and activate it and allow you to transmit and have a conversation. Many radios also have something called tone squelch. Many transceivers will have the ability to transmit other subaudible tones. Receivers can be set up to be squelched for a certain frequency and open the squelch once a specific tone is received. This is also known as DCS, or digital code squelch, as another method to keep the output audio turned on. What this does is, let's say you have an amateur radio hooked up at home and you want the radio on, and your family members are also hams, but you don't want the radio, you don't want to hear traffic from the whole repeater network, or you don't want to hear traffic from the whole simplex frequency while you're away. You can set a DCS, or tone squelch, frequency on the radio and your radio that you're transmitting with and receiving with to only open up that squelch when you transmit on your radio and that tone is specifically received by your radio at home. Repeaters can function as standalone units, or they may have remote inputs to extend their range. Repeaters can also be linked to other repeaters to extend the range of received signal. This could be localized in a county, or it could be on a regional basis, or even statewide. Repeaters can also receive signals on one band and retransmit that signal on another band. For example, a signal may be received on the 2-meter input and then retransmitted on 70 centimeters. Signal reports. So signal reports are common for either simplex or on repeaters. Full quieting with respect to VHF and UHF transmission means a very clear signal with no noise. Scratchy can refer to low to moderate noise, and the term dropping out can signify that your signal is lost occasionally, meaning that if you're driving under a bridge and you're talking on a repeater or simplex, your signal may drop off temporarily until you are clear of any obstruction and don't have any RF obstructions. A broken signal mainly refers to your signal being unreadable. So you may be getting too far away from the repeater, or in an area where there are a lot of obstacles resulting in a very broken RF signal or weak transmission. Flutter or picket fencing, as we covered in previous lectures, refers to a stuttering sound of your signal that's due to multipath propagation or shadowing from nearby objects. Good repeater operating practice: if you are close enough to make a simplex contact, then move off the repeater if you're not having a group conversation with distant hams. So if you're traveling back and forth to work and you just happen to talk to your friend on the way into your workplace in the morning, and you can maintain a good signal, there's probably no reason for you to tie up the repeater with a conversation. You can have a simplex conversation. On the other hand, if your friend lives on the opposite side of the city and you're coming from the opposite direction, then it's improbable that you're going to be able to hear each other on simplex. You're going to need that repeater to bridge that gap between the two stations of communication and talk to each other. The same holds true if you're having a group conversation with several different hams. Most likely you're going to need to utilize that repeater. But if you're just talking to your friend across the street, then there's really no reason to utilize the full power of a repeater and tie it up for other people not to use. Something you can do is to determine if you can actually hear the other party on simplex is when you're communicating with them, you can press the reverse split button on the radio to try to hear that contact directly on the repeater input frequency. So what the reverse split does, instead of hearing that party on the repeater output frequency, you're actually going to see if you can hear that party on the repeater input. So the signal, the frequency you're transmitting on, you're going to be listening on as well. You're not going to be transmitting to the repeater input and listening on a different output, you're actually going to be listening on the same frequency. So utilize the reverse split button to see if you can actually hear the other party's transmission directly. And if you can have a simplex conversation and move off the repeater so other people can use it that may need it. And when you're speaking on a repeater, when you're talking to other people, always remember to allow time between conversations. So if you're speaking to somebody and you end your transmission, or your friend speaking and they end their transmission, make sure you don't resume your conversation immediately within half a second. Allow a pause of maybe a second or two or more to see if there's anybody else that needs to use that repeater immediately. So there could be emergency conversation or a need to report an emergency or emergency traffic, and the other station won't be able to get through if you don't allow enough time between you pressing the push to talk and your other counterpart getting back on the repeater. And if you do have an emergency and you're trying to get in to utilize the repeater, you can use the term break. So if there's a conversation and those two people are appropriate, allowing a space between their conversation, and you need to get into that repeater to report a accident or an emergency, you can use the phrase break, so people will listen, stop their conversation, and allow you to report the emergency traffic. A lot of repeaters have what's called a courtesy beep that signifies the end of a transmission. You can also say over or back to you if needed at your end of your transmission. So when you release that push to talk button and you're speaking on a repeater, that repeater will note that your PTT has been released and then come back with a beep, signifying that it's the other party's turn to resume the conversation. But if the repeater does not have that, you can always use the term over or back to you if you need that to facilitate your conversation. Repeaters also have what's called timeouts. They don't allow for continuous conversation that without a limited period of time. So typically a repeater will time out at, let's say, approximately 3 minutes. That's probably one of the most common time frames. So it does not allow someone to speak greater than 3 minutes uninterrupted. So if that occurs, if that person continues to speak beyond that 3-minute time frame, the repeater will reset itself and not allow any input or transmission and prohibit the conversation for a period of time until it resets itself. So to prevent the repeater timeout, you want to limit your conversation to 3 minutes or be as relatively brief as possible, not to interrupt the flow of conversation, but be brief with your part of the conversation, release the push to talk, and allow the other person to chime in and start speaking. If you need to continue a conversation or continue your train of thought, and it may go beyond that 3-minute time frame, then release the push to talk button. But before you do that, say reset or the term break. As we learned, the term break can mean that you have emergency traffic. A lot of people do that, but a better term may be just to say reset. So if you're coming up to maybe 2 minutes and 50 seconds and you continue to speak, you can say reset and then release the push to talk button and then listen for any incoming traffic or emergency traffic, and then go back to pushing the push to talk button and continue your conversation. So again, you can utilize the term reset or break and then release the push to talk button to reset the repeater timeout sequence, and then go back to your conversation once you listen for any potential breaking in traffic or emergency traffic. The same thing holds true for simplex contacts. If you call CQ or call for a contact on a simplex calling frequency such as 146.52 or 446.00 megahertz on 70 centimeters, and you make a contact, you can ask that person to move to another simplex frequency just out of courtesy. There may be other people who want to use that calling frequency to make a contact with somebody else. You typically identify yourself with your call sign, and to identify yourself with your call sign, you say something like N9WIB. However, in HF or even VHF, that may not be clear to somebody, especially if they have a weak signal and they're not copying you 100%. So what you can do is you can pronounce your call sign in phonetically. So you can use the phonetic alphabet. And the phonetic alphabet is listed here on this page. And yes, we will go through each letter. So A is for Alpha, B is for Bravo, C is for Charlie, D is Delta, E is Echo, F is Foxtrot, G is Golf, H is Hotel, I is India, J is Juliet, K is Kilo, L is Lima, M is Mike, N is November, O is Oscar, P is Papa, Q is Quebec, R is Romeo, S is Sierra, T is Tango, U is Uniform, V is Victor, W is Whiskey, Y is Yankee, and Z is Zulu. There are also Q codes in amateur radio. This is radio shorthand or abbreviations for commonly used phrases. This is in part a little bit reminiscent of the old days when CW was very, very prevalent. However, it's still useful for CW and still very useful for digital communication where you don't necessarily want to spell out the whole word, and you can just use commonly known abbreviations to shorten your transmission and shorten the data rate. So we're not going to be reviewing all Q codes here, just the most commonly used. So the first two are QRM or QRN, Quebec Romeo Mike, Quebec Romeo November. So QRM is man-made noise or interference. And I put emphasis on the M because you can remember it that way. So QRM is man-made, M man-made. And QRN, N for November, is natural noise. So natural noise in the background, such as lightning. So QRM, man-made. Somebody might be tuning right next to your frequency and interfering with you. QRN is just a lot of static in the atmosphere or nearby lightning strikes. They don't necessarily have to be nearby on HF. They can be hundreds of miles away and still interfere, but still pose a problem during the summer months. QSB is signal fading. So once you get on the HF frequencies, you'll notice this more and more. Your signal can improve and then decline and then improve again and then fade away again. So that's called QSB or signal fading. And QRZ is very, very commonly used. So QRZ or QRZ more commonly is who is calling me. So you would say, this is November 9 Whiskey India Bravo, QRZ. That means this is my call sign, who just called me. QSL is another common code, and that has kind of two meanings. So QSL means, did you get my transmission? So the other station, QSL, so you leave it open as a question. So did you get my transmission? And then the other station may come back and say, yes, QSL, I got your transmission, meaning, yes, I acknowledge your transmission. So it can be used as a question mark or a question and also a statement. So did you get my transmission, QSL? And yes, QSL, I did get your transmission. QTH is your location. So right now my QTH is home. So you can ask the other station, what's your QTH? So where are you transmitting from? Maybe they're transmitting from a summit on the air or a parks on the air. So they may say Yosemite National Park or something. So that's my QTH right now. QST, besides being the name of a magazine, means message addressed to all hams. So the magazine is for all hams, or it's a broadcast message that this message is for all hams that are listening, QST. And of course, a QSO is a contact. So thank you for the QSO, or thank you for the conversation, and thank you for the contact. QRP can have dual meanings in a sense. It can mean please lower power or lower your power, or I am transmitting low power. So QRP is typically 5 watts or less. So if a station says I'm operating QRP, they should be operating 5 watts or less. So another easy way to identify your location is grid location, and this is called a Maidenhead locator system, or grid squares. The Earth's surface is essentially divided into a series of rectangles based on latitude and longitude. And the grid location is identified by a combination of letters and numbers. It could be 4 digits or it could be longer, 6 digits. So 4-digit code represents an area 1 degree latitude by 2 degrees longitude. So remember, 4 digits represents 1 degree latitude by 2 degrees longitude. And as I mentioned previously, the code can be longer for greater precision. So instead of that 1 degree latitude by 2 degrees longitude representing the 4-digit code, a 6-digit code would represent something a little more precise and smaller. And this is an example of the grid map. So you can see that South Central United States has the grid identifier EM for the letters, or Echo Mike. And the Midwest has Echo November, EN. And Montana, Wyoming, Idaho has DN, or Delta November. So DX and contesting. DX stands for a distance station. So DX is a distance station. If you're referring to the high frequency bands, DX will be a DX contact will be thousands of miles away. So you may hear stations calling CQ for a DX station. So that means they don't necessarily want to talk to a station that's a few hundred miles away or 800 miles away. They're looking for a DX. Some people may say in the United States, DX Europe, or DX South Africa, or DX Japan, to be a little more clear on the type of distance station they're looking for. VHF also has DX contacts. If you're talking about maybe FM broadcast or single sideband, VHF DX is typically over the horizon. So for FM single sideband or CW, that's going to be maybe a few hundred miles. Radio contests. So there are many different radio contests you can actually enter into. There are what's called state QSO parties, or state contact parties, where everyone that would like to gets involved from a state on a certain day of the year, and they try to make as many contacts as possible. And depending on the power they're operating, depending on if they're mobile or at home, they are assigned a certain number of points for the contacts they make. And then those points are accumulated and somebody will win the contest. And there may be a very minimal prize or a plaque or just an acknowledgement. So it's not necessarily done for money, but just for enjoyment. There are also other ways to get involved by trying to work all states on HF radio. So if you've made a contact in every single state, you can get a certificate that states you've worked all states. And with HF, there's also something called DXCC, or DX Century Club, meaning that you have confirmed that you've worked 100 countries. So that's another certificate you can get for your ham radio efforts. Okay, that's going to wrap it up for part 1 of the communication lecture. So we'll cover more stuff in the second part of this series, obviously, in lecture number 17. But in this presentation, we learned about communicating on HF frequencies, on VHF frequencies, the different modes of communication. We learned about, what else? We learned about the different Q codes and the phonetic alphabet. And hopefully you guys enjoyed it. and we'll see you next time on the second part of the communication lecture. And if you do like our series, please feel free to support our channel and go to radiosignals.org and make a contribution. Talk to you next time. 73.